Good morning. I hope everyone's doing well today. Wherever you're joining us from, just wanted to do a quick shout out and just say thanks for joining. This session we'll definitely be going through and answering quite a few of your questions. So if you have any questions, please feel free to share them with us, and we'll do the best we can to go through and answer as many as we can. So this is a sort of a new thing that we started introducing early in January. We did switch it to be a monthly session to give guys more of an opportunity to write down the questions that they wanted to ask, and then join us for about an hour where we can run through and see how we can help share the knowledge of Mozaik and go through all of your questions. So I'll switch across to sharing my screen and run through just one or two quick things first, and we will jump into your question. So if you have a question, drop it in the comment area, and as soon as I start seeing them come through, I will dive into your questions. So one thing I wanted to point out or note is that we are about to release our CADmate V12 library. We're putting the finishing touches on that today and hope to have that released early next week. Just a quick note on sort of some of the new additions there. We've gone through and sort of done quite a few things. We will create a video on all of the new content and how to update to that for you guys early next week as well. There is quite a few new things and updated items in that. Some of the highlighted things would be some of the vent cabinets that we've been working on. So you'll see here in the base cabinets, we've now included the ability to have a vent on the actual door. So this is both a graphical thing and a item that will cut the door out. So you can see a nice sort of preview of this on the door here. And that will show both in the hidden mode and the field mode, and also wireframe, of course. So that's going to be a nice addition. That is actually parametric according to some parameters. So you can control whether you want that on the bottom of the door or the top of the door by simply changing a value there. And then also changing the position of where it sits on the door and the size of the vent. So we've done a whole edition of these across different types of products. So you'll see the vent items on base cabinets, 1 and 2 door options, but also things like toe bases and bulkhead cabinets as well, or bulkheads as well, I should say. So there's quite a few new additions there relating to the vents. There's one of the bit of feedback we had from you guys. So hopefully that will be something you can put to some good use. A couple of other quick things while I wait for the questions to come through. On the toe bases themselves, we've added a few new items there as well. So you'll see that we've got a toe with dados. So we've basically gone through and shaped these components to have a qualified dado, or a mortise and tenon as it's also known. So if I was just to explode this cabinet out and show you this, what you'll see there is we've got a qualified dado construction happening. So I'll do this in a high detail, give you a bit more of a perspective. So that way we've got a qualified dado happening on all of the sleepers, and then the matching groove or mortise on the front and back of that kick, as well as some screw fastener fixings as well. So that product will be available in the V12 library. We've also added some options to make these easier to wrap around a kick as well. So wrap around a dishwasher, I should say. So we've got some parameter choices in here for you to actually control a dishwasher cutout and the position of that dishwasher cutout. So a few new choices there, giving you the chance to sort of, I guess, in some way, shape or form, shape that toe kick around for a dishwasher cutout. So that's sort of been another commonly requested thing that we've noticed. We've also added for the order entry, cut to size or refacing sort of companies out there, a few new products as well in the door parts of the order entry components. So things like this you would typically do in the order tab, and just to scroll down and give you a bit of a preview there. If we look in the door parts of the order entry, we've got an option here for the Bloom door reface and the headitch door reface. So if I drag one of those components out, you can simply set your door size, so what you want that to be. And if you double click to go into that, and on the parameters tab, we've added a bunch of parameters here for you to easily do a reface of a kitchen, or a door, I should say. So we've got the ability to control the cup inset. So just to show you this side by side. So you can control the quantity of hinges. So you can see here that hinge 1 and hinge 2 is listed. If I was to drop hinge 1 to 200, you'll see that that moves up. And if I drop hinge 2 to 200, you'll see that moves down. So you can control the position of those nice and easily. And then the hinge 3, 4, and 5 all work from the bottom of the door. So if you've measured from the bottom of the door up 600 to the third hinge, that's what you would enter there. If you've measured sort of 1100 to the next hinge, you would enter that there. So you can easily sort of control the position of those from an order entry perspective, as well as the cup hole diameter, depth, and the anchor hole diameter and depth. Because obviously, if you're doing a reface, maybe they're going to use their existing hinges, and you might not want to drill them for a push-in hinge or a knock-in hinge. So you might be, just spot boring them 5 mil and 2 or 3 mil deep. So you've got the ability to change that on the fly nice and easily. And you can also control how far in the cup starts from the edge of the hinge. So you could drop that in at like 2 or 3 mil as opposed to 5 mil or whatever it needs to be for that specific door. Maybe it's overlapping an end panel and needs to go across 18 mil, something like that. So you've got a bit of ability there to easily shuffle these around. Same thing for the drawer fronts as well. So if I open up a drawer front, we've sort of done the same thing here. Got the wrong product selected there, so something we'll tidy up before the release, obviously. Looking at a couple of the other options there, we've got some new products for the wardrobe sector. So if we had a look under the sliding door robe, so we've included here in the wardrobe sliding door robe option a 2 and a 3 door option. This is a visual of a sliding door, so let's go ahead and make sure we've got all this enabled. We can show you what's going on here. I'll just go to my elevation view and show you this. Here we go. So you can see that these are just sliding doors. You can go ahead and click on that and easily resize these, change the height, width, etc. And obviously outset them from a wall or drop them on an invisible wall outset from the wall itself. That way you can still put products on the wall nice and easily and then use that as sort of sliding door examples. So a couple of new products there. Also, just delete that one. Also in the wardrobe area, we've added some options for shoe shelving as well. So if we have a look at shoe shelves, we've got a tall cabinet with shoe shelves inside it and then just shoe shelves on their own. If we have a look at this product here, this is a sort of custom design product with some slanted shelves, as you'll see. Now, these particular shelves here, if you go into parameters, you've got the ability to control the quantity up to 6. So if I said 1, I'll have 1 shelf. If I have 5, I'll have 5 shelves. And you can control the tilt angle. So it's on 10 degrees at the moment. So if I put that to 20 degrees, there will be a greater tilt. So you can control that, as well as the nosing at the front. So if you don't want the lip or nosing on, you can set that to 0. If you want it on, you can enter a size for what you would like that nosing to be. And then you can also control how far you want to set these back from the front of the product as well. So a nice addition there. And you've also got the ability for those to be on their own without being inside of a product. That way you can certainly sort of reduce that size down and fit them inside another area of an item. So nice little addition there. Also added some tall open products and base wall and tall for products referring to the angled cabinets as well, or like wine angled cabinets. So we've got some new options there as well. I will put together a video of that because I don't have those loaded in this particular edition of the library, but plenty of new stuff coming out there for sure. Also added a bunch of new handle designs, ones that are specific sort of sizes as well. It's a common sort of thing that we come across. People that want to drill handles definitely want them have the ability to sort of control between 90, 128, 160, 192, all the sort of standard 32 mil increments. So this will all be available to you shortly. As I mentioned at the start, we're planning on releasing this early next week. Plenty of other stuff there, but I don't want to sort of spend too much of your time going through this in this particular video, as this is more about the training sort of thing. So just thought I'd open with that. There's quite a few questions coming through now, so I'm going to switch across and start diving into those questions. So let's take a look. Brock is asking, let's see, I'll just put that question on the screen. So, can you run through how to turn off the edge banding for painted and panels? So, a couple of things with edge banding. You can control that via your edge banding template, but you can also control that via the door style. So, if you're talking about a door panel or a door style itself, if you go into libraries doors, one thing I'll point out first of all, there's an option on the right hand side on every door style whether or not that particular door style applies banding. So, a very simplistic way of managing that is to simply have something called a painted door or a painted end panel where applied banding is unticked. And that will overrule everything else. So that way, uh, if you're still telling Mozaik to apply an edge band to that particular edge, but the applied banding on the door style is ticked off, then it will basically disable that altogether. So that would be the easiest way to manage it. But while we're talking about the topics of edge banding in general, I will point out one thing that you should really look into is which edge banding template your library is currently set to look at. So if we have a look in the job parameters and we come down to the other folder, there's an area called band temp, which stands for banding template, and it's asking you which edge banding template you would like to assign. Now you can actually have as many of these as you need, and they can be for different purposes. So to explain kind of a little bit more in detail about that, what I'll do is I'll dive in and show you how that works. So if we go into the libraries area and we come down to edge band assignments, what you're going to see in here is all those standard choices that we just saw on the left-hand side in the job parameters. So if we come down to standard edging, this is a list basically that shows all of the standard components and then what they're set to by default for a base or a wall product. And the answer can be different for a base and a wall. So for example, you might choose on your ends of a base cabinet to edge them at the front edge of the base cabinet. Okay, so it's got edge banding 1 assigned to the front edge. Now, if I look at a wall cabinet, it's the same at the moment, and you can have it marked just set same as base, or you can click in there and decide to do it differently. So perhaps you edge band the front and the bottom edge of your overhead or wall cabinets. That's how you can go ahead and set that as a standard rule. And you can go through each of the different part types and define how you would like those to be banded as a standard rule. So it's definitely well worth going through and doing that to make sure that every product you drag and drop onto the screen has the standard edge banding rules assigned correctly. Now, to give you a bit of an idea, you can click that question mark. Highly recommended. It's a really fantastic resource in Mozaik. If I scroll down about to page 3 here, I'll just show you an example of kind of the default way that most of Mozaik customers are going to be using this. So edge banding 1, we typically refer to as the front edge of a cabinet. Okay, so you can see that sort of teal green color-coded option there. So edge band 1 in our predefined library is set as the front edge of every cabinet component. Now, edge band 2 is assigned to things like adjustable shelves and maybe back rails like this. So they're edge band in positions that are typically internal of the cabinet and maybe not seen through a door. So that would be edge banding 2. And then edge banding 3, by default, is the edges of doors and drawer fronts. And then lastly, edge banding 4 by default is set to the edge bands that are on the top of, or any position really, of a drawer box. So they're the drawer box and tray box edge banding options. Now, you don't have to use it that way. That's just a suggested way. Some people use these to control differences in what type of edge they want to assign. So they might have one template set up where they're applying edge banding 3 to the front edge of their cabinet as well. That way, the front of the cabinets match the doors. So to do that, you could easily just go ahead and create a new edge banding template, and you might call this like match doors or something like that. Again, just use whatever wording suits you. Then go ahead and simply go to the door component. Actually, in this case, we're going to go to the unfinished end. And instead of applying number 1, we're going to apply number 3. And then we're going to go to all the components that we need to change that on. So the top, same thing, banding number 3. The bottom, same thing. We'll go ahead and apply banding number 3 in that situation. And anywhere else I want that to be. And so then what happens here, I can change that on a particular product or a group of products or the entire job. So in this job, if I wanted my edge banding on the front of the cabinet to match the same banding for the doors, I can now apply that template. And then when I go ahead and drag out a cabinet and take a look at this product, you'll see that the edges are edged in number 3. And going into that, the edge banding will show as number 3, which in this case happens to be PVC color 1 millimeter. So that's the final stage of that whole edge banding topic, is really looking at your edge banding material templates. So if I go into the banding here, you'll see if I look at this particular banding that I've got applied, my banding number 1, 2, and 4 are all PVC white 1 millimeter, and my edge band 3 is set to PVC color 1 millimeter. So by applying that template to this job in the settings, that's then the link that pulls it all together to control what we're doing. So easy way to manage sort of banding really is just a combination of those banding assignments with your material template libraries, and then just whether or not you want a particular product to have that edge banding. So if you're dragging a panel separately from a library like this, it really depends on the panel type. So if I'm going to pull two products out here. I'll put this one on, and then I'll bring out a door panel just to show you the difference here. So I'm just going to push this one across. So we've got two panels. They look the same, but internally they're different. If we go into the parts list here, this particular panel type is made from a finished end. So it's going to get its rules from the edge banding assignments of what the finished end is told to do. So we'll go into the edge banding there. The finished end is told to band in number 3 on the bottom, front, and top. Now, if I go to the other option there, the door panel, this particular option is made of a door product. And by default, a door is going to be banded all the way around. In this particular case, this one's been modified to band on the bottom edge. So you can control this individually. You could change the banding there and save it back into your library. Just keep in mind, if you're using a door panel and that particular door style in the door library is told not to band, that will overrule everything from above. So a little bit of a sort of detailed topic, but hopefully that sort of covers the question overall of what you're asking there. You sort of did ask a follow-up question about you've got it set to no edging in your settings materials tab, but it's still taking edging off for my flat panels. If you've got it set to no edging here on your materials tab, so we go back to the materials tab, if you've got it set to no edging there, I would recommend just clicking on the view option there and checking that your no edging template is actually has a thickness of 0 for the materials that are assigned, because maybe your no edging template has an actual material assigned within it. That would be the only thing that I could think that would actually trigger that to happen. So take a look into that. If you're still having trouble with it, send it through to our help desk and we'll open the job up and have a look at it. Quick note on that appears to be fixed in 12.0.8. So if you do go to help and email current job to help desk and you're running the latest version of Mozaik, you should be able to send that through now successfully. So a nice addition there, having that sorted out. Okay, Chris is saying wanting to add a cove bit for doing cove panel 63 mil wide. There is nothing like it in the tools. Can I copy a V-Groove tool and just use the V-Groove doors with the new tool set, or is there a better way? Yeah, look, definitely in terms of creating the Cove tool itself, if I go into the optimizer, I'll just give you a bit of a idea how to go about that. So let's just make this optimizer a bit bigger, and we'll go into CNC tooling. So if you don't have anything in your library, and there's a big long list of example tools, so you're probably going to find something that is similar. If you look through sort of the Vortex or the Great Lakes or the Royce Air tools, you're going to find something similar. It's a little bit challenging because you might not know the product codes specifically that refer to that. But for example, if you just click on each one, you will see a preview picture there. So you're probably going to find something similar, like that's a Cove raised panel door. And if I click on tool shape, that is showing me a Cove shape there. But look, these tool shapes are easy enough to create from a basic perspective. You don't necessarily need to sort of map out the entire tool holder the way it would specifically look. You're more than welcome to if you'd like to, but just to show you a real basic idea of how to create that tool, you'd click the Add Tool button, and I'm just going to call this my Cove tool. Okay, so you can click in here and assign a picture. If you want, you can download a photo from your tooling supplier and drop that into your CNC images folder and then assign that as your preview picture. Again, it's not necessary. You can do it without that. But if I jump in now and look at the other settings, we want to enter the diameter, which would be the overall width of that tool. So for this example, you said your diameter was 63 mil wide. So I'm going to enter 63. You can control the pass depth and plunge depth. So, plunge depth being more for drilling, pass depth being more for a routing operation. So, look, if I want this to go in increments of a certain value, I can enter that there. Probably no need to assign a limit to this one because you're probably only going to be doing that a few millimeters deep anyway, depending on what you're trying to achieve. You've got your step over value. That's more for pocketing. Again, that's probably not relevant here. The pocket ramp, again, more for pocketing, probably not relevant for what you're doing here. So then you've got your feeds and your speeds, and obviously this is going to be different depending on the different tool or different tool and the machine that you're using. So some machines aren't going to read these settings at all. Other machines will. So I'm just going to keep this very general in nature. I would probably want to set that around about 16,000 revolutions per minute as my feed rate, as my sort of spindle speed, sorry. I'm going to set a minimum of 12,000 on that one. For my feed rate, this is debatable because it really depends on what material you cut in and how deep you're planning on going with this tool. So, I would definitely talk to your tooling provider about that to find out what their recommendations are. But look, I'm going to enter something here. I'm going to say, look, my minimum as 3,000 and my max as 6,000. And my plunge rate, I'm going to come in at 1,000 as a minimum and let's say 2,000 as my max. Now, again, the speeds are very general in nature, and obviously that's in millimeters per minute. You can convert that to inches per minute if needed by just clicking on the inches unit option. So coming down here to the application, really this is going to be a CNC door. Okay, so the CNC door, the reason why we're ticking that option is so we have the ability to shape the tool. So that's probably the key link there. So we're going to click Tool Shape, and let's just make this a bit larger. So what we're actually looking at here is half of the tool. So the 63 millimeters, you divide that by 2, you would get 31.5. And if I click on this point here, you'll see that's exactly what that X value is. It's 31.5. So we're drawing in half of the tool, and Mozaik's going to mirror that for the other half. So what you want to do there really is just map out the shape of the tool. If you think about it, like the whole tool itself wouldn't be 31.5. There would be a tool holder portion. That's less important because we're not really using that portion of the tool to cut into the door. It's more just from a visual perspective. So I'm going to go ahead and just assume it's like a half inch or a 10 millimeter sort of holder, usually probably half inch, which would be 6.35 as the half of that half inch, or a quarter inch, I should say. And then let's go ahead and add another point there and bring that across to match. And then obviously how far down that comes will depend on other specs that I don't have in front of me. So, if you think about this, you're probably going to have like a matching point like this, something like that. And then this will be radiused or beveled off. So the radius value is then going to be determined by what you want it to be. If I put 31.5, for example, let's just do 30 millimeters. You can see that because I haven't gone high enough, I'm cutting that off. So this height here is something that I would need to get from your tooling provider. Otherwise, if I just reduce that down to less than what the Y value is of this was 26 mil, I've gone 25, and that's going to create that sort of cove bellowing shape. Now, you can obviously sort of tweak that to suit what you need it to be. But that's the kind of key to drawing something in. And then Mozaik's going to use that particular profile shaped into the door by you drawing a line into the door and then showing you the result of that. So adding the tool's one thing, adding the tool to your tool set then would be the other thing. So, for most people, you would probably assume that the tool number is important. Again, you can't assume that for every machine. For BSEs, it's a tool name. For a Wiki machine or a HOMAG, it would be the mapped tool number. For a Felder machine, it would be the mapped tool number. However, for most people, it is, or most other machines on the market, it would be this tool number that is important. So you would be inserting that into your tool set in the correct line for that to match where you're putting that tool on your machine. So that's the other aspect that will most likely be important for you. And then, look, a couple of things you can do here. A real simple way. Yes, you can edit our vGroove door or make a copy of that and then assign the tool itself to that particular one. So you could go into your tool library. As mentioned, we've got our sort of vGroove options that parametric that you can change. So you can go into that particular door and make a copy of that. And you might call this your Cove option. And then if you go in and edit that and go to your operations, each of those toolpaths are linked to the 90-degree sharp corner tool. You would go in and select that and then choose to map that to your new Cove tool. So if I go down and change one of these to my Cove tool, as you will see, and obviously I'll just do that to one of the ones that are actually visual on the screen at the moment. So I'll just go down and change this and go to 3D. And as you can see, that one's showing me the result of that Cove tool now at that depth. So you could certainly do it that way for sure. You might even want to use the built-in beading function in Mozaik too. I mean, obviously the depth would be the other factor that you would want to control there. So thinking about that, like at the moment, that's 2 mil deep. You might want to change that. For example, let's go a bit deeper on that particular line. That's this toolpath here. I'm going to go ahead and make it sort of 4 mil deep and take a look at how that looks. So 4 mil deep, I think it looks a bit better. And again, it's getting that radius right, and then the repeat of those lines right as well. So you could definitely do it that way, go through and change all of the lines. That's the safest way to do it. There is like a bit of a cheat in the background where you can export the door, open up the text file, do a find and replace for the different tool ID numbers, and then import it back in. Very easy to get wrong and completely mess up, but the safest way would be to go through and change those lines individually. The other thing I mentioned was if I go into the settings and beading area, you've got the ability to select a tool there. So you could come down here and make that your Cove tool. And then you can go ahead and choose either single or double, and then the spacing between, as well as the depth of those routes. And so with those ones, if I created a new door called Cove Bead, example, and the way this one works, if you tick the apply beading option, it's just going to do beaded lines. It starts in the middle and works out, and then wherever the variance is on the door becomes the edges. So that particular one would be repeating that same style. And as you sort of can see here, you're getting that shape. Again, the depth of that is really then going to be the important thing. So if I go deeper again, you're going, and the spacing obviously as well, you're going to get more of that sort of cove shape coming through. So you can play around in the settings there as to the spacing and the depth of that. So couple of options for how you could go about it. As I mentioned, it's sort of a case of maybe that's starting to look a bit better now because we're starting to get that flat spot between, which usually those doors have. So certainly achievable. Various ways that you could go about it, but that's kind of a bit of an idea of how I'd approach it. All right. So Philippe is asking, what would be the easiest way to send cabinets to a remake in the optimizer when you have multiple rooms and you only need one or more cabinets per room to redo? So let's just go ahead and make a couple of rooms. So let's jump into another room here and we'll draw a wall. And we'll autofill this with some products. And we'll go to cut list. So one thing that you can do here in the room is you can go down and you can choose a room specifically. So I could say, look, room number 2, and that filters to just the parts for that particular room. Now, if I wanted to remake all the parts from cabinet number 2 in this room, I could go ahead and change my cabinet instead of all to 2 and then press enter, and it will filter the list now just to products or number 2 in room number 2. Now, if I approach that a little bit different, if I go to the select option and I tick room 1 and 2, what it will do then, it'll be showing me the result of both of those rooms. And if I go items 1 and 2, then I'm getting items room 1, product 1, room 2, product 1 and 2. So you can see that I can control multiple rooms there. The challenge will be getting exactly the cabinets that you want from that room, because you might want room number 1 and cabinet number 1, but you might want room number 2 and cabinet number 15. You're going to get the parts for product 1 in both of those rooms. So you would need to then probably delete those components out in the optimizer. But it's going to filter it pretty drastically for you to only a couple of cabinets that you need. And then when you're in the optimizer, simply find those components and delete out the ones that you no longer need. That would be your sort of best approach for that one. Yep, Adam is asking what was the shoe shelf under? And then the next question was, is that in library V12? Yes, that's in library V12, and that's coming next week. No worries, Brock. Hopefully that answered your question and cleared that up for you. Alex is asking, is there a way to set the face of fillers to always optimize to a certain width? Ideally, would like them to get optimized around 150, so they aren't wide enough so they are wide enough to be scribed easily. So one thing we've done with the fillers in our library is we've set a visual and a non-visual component. So if we take a look here and we drag out let's have a look at one of these fillers. Okay. And we'll go into the edit of that item and look at the parts list. We have 2 components, a filler and a display filler. So the filler is actually the component that's going to be cut, and the display filler is the one that's displayed to you. Idea being that you might want to make that quite small, so you might say this is only 20 millimeters wide, right? Obviously, you're not going to want to cut a 20 millimeter wide, or just under an inch wide component, right? So coming into that, if we go to the parts list, your filler itself is still at 80 millimeters. I mean, if you want that to be 150, no dramas, you can certainly change that. You can just go into edit, and the width here is set to 80. And you can see here that if the width is less than 80 of the filler, it's then going to be 80. So what you could do there is you could just change both these numbers to 150 and press update and OK. And now your filler is going to, your cut filler is going to come through at 150 instead of 80. And then just save that back into your library for the next time you use it. So as mentioned, displayed at 20 millimeters. But if we look at this is item number, let's see, item number N2. So with the item number 2, just a note on that, you don't necessarily need to not give these things a number. On the info tab, you can certainly control whether this is auto numbered. So you can turn that on if you want your fillers, panels, those things to have a standard item number. So you can see now that is product number 2. And then when I go into my cut list and select that material and go to, I'm in room number 1, product number 2, you can see here that it is edge band on either side. So it's coming through at 148. And there's a comment on that says oversized filler for the CNC. So when I go through to the optimizer, I'm not getting my display filler. I'm only getting my final product, which is the cut size filler. So certainly achievable. As mentioned, that's kind of the way our standard fillers are set up in the CADMate library. That's both in the CADMate V11 and the upcoming CADMate V12 library. All right, so let's see. Andrew is saying he's drawing one job in 33 mm thick back panel with horizontal grain. What is the best solution to do it? I know how to use a 16 mm back panel with horizontal grain, but not the 33 millimeters. Thanks in advance. Step 1 would be to go ahead and set up your material itself. So if you go into libraries materials, and we just make this a little bit bigger, it'd be making sure, that you have a material thickness with the grain set correctly. So you'll see in our sort of standard library, there are some grain 1 32 mil options. You've mentioned 33 mil as your choice, so perhaps you just want to go ahead and click on, say, grain 132, press clipboard copy, and then clipboard paste. That's going to paste that at the bottom of this list. I'm going to go ahead and make that 33 millimeters and just get rid of the word copy and go ahead and change the thickness to 33. And it's going to ask you if it's too thick and is it correct. Just say yes to confirm. So now that I've got my material in there, the next step would be to create the material template. So if I go into libraries and material templates, so if you're talking about making the back of a cabinet a 33 mil thickness, let's go ahead and just select like a standard option. So you can see here, you've got options that say like whiteboard with grain 1 for your finished components, right? I'm going to just start with that, even though that's on 16 mil. I'm going to press new there, and I'm going to give this a name. So for you could call it, white 16 mil plus 33 mil back, or whatever you wanted to refer to it as. So I'm just going to say white HMR 16 millimeters plus 33 millimeter grain 1. Okay. And what I'm going to do in this particular case is find my back, and whether it's a finished back or an unfinished back depends on what you want to do. But you could do it in either approach. You could change your regular back to that if you wanted all of the cabinets using this to be an unfinished back to be that material. Otherwise, you could go ahead and grab the finished back component and then drop that list down, scroll down, and find that new material. So that's going to be in your library here now under grain 1 33 millimeters. So just having a look, it's probably at the bottom of this list as it is. And we're going to click OK there. Let's just use this product as the example. So if I go to this product's info tab and go to the case selection, I can now drop that down and find that new option. So white HMR 16 millimeters with the 33 millimeter grain 1 back. And then the last step would be, because I assigned it as a finished back, I'm going to click on this edge, and rather than it be a back, I'm going to go ahead and make sure I change that to a finished back. And then what you'll see straight away is that now my back thickness is the 33 millimeters. So that's how you can control that particular component being that way. If you want to do it like whether it's vertical grain or horizontal grain, you can control that by either rotating the part or changing the graphic assigned to that particular component too. So in this particular case, I could go ahead and choose a texture for the exterior texture that was a grain material, and you can have different directions on that as well. So you've certainly got the ability to control the material really easily. Hopefully that answers your question. Okay, and you've also said, and for the open shelf with grain, how do you make the back panel to be horizontal grain? The direction of horizontal and vertical really depends on the part type that you select as well. So with the way Mozaik works is that part types have a certain direction assigned to them. So let's just look at, say, the edge of this cabinet, for example, or even just using the back on this one. So at the moment, that's a finished back, right? If I go ahead and make that something else, like for example, a toe component, you'll see that the back direction goes in the horizontal method. So a real easy trick is really just to change the direction or change the part type to a toe component, and then it will be horizontal by default. So that's a real quick and easy trick to change in and making it control it as horizontal rather than vertical. Okay, I've got 3 different colors in a job. How do I set up edge tape for 3 colors plus white plus carcass? So if you've got, let's just go into this room too. So let's say all of these bottom cabinets were one particular option. You could highlight all of them by dragging a window over them, right click, and then go down to your override material templates. And you've got the ability here to override both the doors, the drawer boxes, the cabinets, and the banding. So if you wanted to select a different banding for this particular option, so for example, let's say this one's going to be 1mm PVC white with black edging for the doors, and I'd obviously go ahead and change my doors to black material in that particular case. And then let's say I do these 2 cabinets here as same thing, override material templates, and I'm going to make these ones, let's say color 2 18mm, and my banding is going to go to white for the cabinets, but with color 2 for the doors. And then lastly, these 2 are going to be a different selection. So again, you can go through, I'm going to go color 3 18 mil for this one, and then my banding would go to the color 3. So very easy to control them on the fly. And if you go into your cabinet there, you'll see your parts. And if I go to, you can see, the parts are obviously assigned correctly there. And if I go into my edge banding, you can see that PVC black is assigned for these ones. If I jump out of there and go into one of the other ones, you can see these are set to color 3. And if I go in and show you the edge banding, you can see that the edge banding's on color 3. So pretty easy just by multi-selecting products. And you can do that on both plan and elevation view really easily. And then when you go to your pricing and run a pricing report on materials or a quote, you'll see that it separates the banding as well into those different categories, so you know the correct quantities of each one. So that's how I would approach that one. No worries, Adam. Yep, we'll certainly notify everyone on Facebook once our library is released next week. No worries, Alex. All good. No worries. Thank you. Appreciate the feedback. Can you make a video on the flip side operation to how to set it up properly? Cool. Let's just talk a little bit about that. We do have a video on our standard sort of help site as well. So just to give you a bit of an idea there, if I'll just drag this over so you can see it. So if you go to help.cadmate.com.au and if you just type the word flip, there's two main videos that you'd want to watch. One of them would be how to create flip sheet programs, and that's just going to be a step-by-step guide on how to do that. I'll go through and briefly explain it now as well. So basically, you've got a bit of a guide there that you can use. And the other one that appears in the flip area would be how to test the alignment of your flip sheet parts. And this is a really big thing. On most machines, and generally I connect around 4 or 5 CNC machines to Mozaik every single day. And I would say 95% of the machines that I connect to Mozaik are not correctly aligned to the pins. When a lot of machine techs install the CNC machines, they're used to just single-sided machining, right? So they've got a bit of leeway to play with, which is the leeway is the trim value that you're setting around the sheet, right? Typically that's like a 1/4 inch or it's 5 millimeters or something like that. Now the trouble is that if the machine's out by 1 or 2 millimeters, you're going to notice that when you start doing flip side machining. It's very easy to fix though on almost every CNC machine, and all it is really is what's known as a global origin. So a global origin, as depicted in this picture, is really just the distance from the center of the router to the pins in X and Y. And every machine has an origin table that controls what that value is. On some machines, it's G54 or G55 or G59. Other machines, it's just a global origin value. So speak to your machine provider about how to control your global origins. And then all you need to do is something really simple. It's just setting up a test to cut a component 100 millimeters wide or just a really standard easy width and a set distance off the pins in X and Y. And then simply run that test, measure where it is, and then go ahead and see if it's out by 1 or 2 millimeters. All you need to do there would be to edit the global origin table to adjust the X and Y offset to get that bang on perfect to your pins. Once you've got that established, your flip sheets are going to run perfectly, but that's something that's not controlled by Mozaik. It is something that is controlled by your machine. Now, a real quick way of setting up this alignment test, I'm just going to go ahead and create a new one here, and I'm just going to call this alignment. Okay, and what I'm going to do, I've already got one called that, so I'm just going to call it alignment. And I'm going to go into parts. So choose the material. It can be anything really. It doesn't matter for that. I'm simply going to make my part. You can make it like 4 inches by 4 inches or 5 inches by 5 inches, or I'm just going to make it 100 millimeters by 100 millimeters, right? And I'm also going to drill a hole right in the middle of that component. Now, ideally, I would want to choose a hole that is the reference drill on my machine. I don't want to overcomplicate it, but if your reference drill was a 5 millimeter drill, pick that. if it was an 8 millimeter drill, I'd pick that. Choose whichever tool happens to be your reference drill. And on the material page here, I'm actually going to set my trim to 50 millimeters by 50 millimeters, just to make it really obvious. I want it to be a decent size away from the pins. Now I'm going to go ahead and optimize that. Now, depending on your machine, it'll either be down here or up in the top left-hand corner as your reference. Now, what you can do there is, I'm just going to hide the question for a second so you can see this a bit clearer. Now, with this, I'm going to go ahead and press Edit Sheet. And I'm going to edit the small part handling. So I'm going to override the small part handling. And what I'm going to do here is go full sheet skin. And I'm going to leave a millimeter at the bottom of this so it doesn't move on the machine. And I'm going to say cut that out manually. And I don't want to have a skin offset. So my goal here is to cut it the exact correct size in one hit without doing a skin offset. So maybe I'll just leave 2 millimeters at the bottom, for example. Something like that. So basically we want to make sure that it's not cutting through. That way the part doesn't move on the machine because it's a relatively small component. And then the goal here would be to measure from the edge of your sheet or edge of your piece to the part, and making sure that the part is exactly 50 millimeters in, or whatever you set in your trim width, in from the edge of the sheet. That's the critical thing. If you measure that as 51 or 49 or 47 or anything other than 50, you need to adjust your global origins on the machine to make that exactly 50, because that means that when your CNC has been set up, the alignment hasn't been done 100% perfect to your pins. And that is incredibly common. Like I said, 95% of machines that I see are not done correctly. They're out by at least 1 or 2 millimeters. So if you do that, you're going to get it perfect every time. And the reference drill being in the middle is so that way you can measure in and make sure that it is centered in X and Y, because sometimes your drill bank, if you have a separate multi-drill head, is using a different reference, and that might need to be tweaked by a millimeter or two to get that perfect. So that's typically the best thing to do from an alignment perspective. Now, just talking about flip sheets in general, I'm going to step back and jump into this job and go ahead. I'm just going to change this job to be a shaker style, just so we can have some flip side machining present. And we're going to go into cut list here, and we're going to go ahead and optimize these doors. Even though they're on color one, obviously it would be a different material like white satin or something like that. But for the purpose of the exercise, I'm just going to leave it at that so we don't lose too much time. Now, on the optimize tab, if you're running version 12 of Mozaik, I highly recommend ticking on these two options by default, which is the ability to auto flip parts. That's brand new in version 12 of Mozaik. So you no longer have to then flip the parts manually after. So just if you're using double-sided materials all the time, just simply have that ticked on. It's sticky, which means it will remain ticked on until you untick it, so you don't have to remember to do it each time. And the sequence flip side parts first would be the other option, which is basically saying that if you do have flip side components mixed in with non-flip side components, it's going to put all the flipped ones on the first X number of sheets, which means you're flipping less of the sheets. Okay, so coming back for a second, the three key components that are critical for getting flip side working correctly is the sheet size, the trim value, and the square and cut trim. I'll run through each three now. So you've got your width and length of your sheet. If you're out by more than your trim value, if you're estimating 1210 there for your sheet width, and you're allowing 5 mil for your trim, and your sheet actually measures, let's say, 1203 instead of 1210, that's 8 millimeters difference. We're only allowing 5 millimeters for our trim. You're already out by 3 millimeters. So really key component is making sure that you're not overestimating the width. If anything, with the width, I would prefer to underestimate than overestimate. So my rule of thumb is for the width, I underestimate. For the length, I overestimate. And I'll explain why shortly. So I would, let's say, I'm just going to go say 1205 on the width. And for my length, I'm going to bump that up to 2420. Ideally, if you can measure the sheets and know exactly what they are, awesome. Put in the exact measurements, maybe slightly longer on the length, and I'll get to that shortly. For the width trim and the length trim, ideally you want to be doing more than what you would on a regular sheet, right? Because we're now doing it twice. We're machining one side, squaring it off, flipping it over, and then having an inset. So allowing 5 millimeters or a quarter inch is just going to be so tight there that you're leaving yourself room for error. So I would recommend going at least 10 millimeters there, or close to a half inch, and then having it set there as what those values are. Okay, so coming through to optimize, let's go through and optimize these components. Looks like I haven't actually changed my door styles, so that's right, I actually overrode those. So let's just put a, let's go back and fix that, and then we'll come back to this. So let me sort that out first. So let's see, we're in room number 2. Okay, so my base doors have definitely got shaker on them, and they were a different material. They were black. Okay, so I've chosen the wrong material there. I'm going to go to black and optimize these ones. So just recapping, we're going to change our sheet size and we're going to change our trim size for the flip side sheets. So I'm going to go 1205. I'm going to reduce that one and I'm going to increase this one. And I'm going to increase my trims to 10 millimeters by 10 millimeters. And now I'm going to go ahead and nest those. Okay, now I've got my flip sheet. So looking at this, you've got your part starting 10 millimeters in for the reference. Okay, and then when I'll show you this, like, first of all, from a high level, where if I click generate G code and create flip sheet program and okay, it's going to ask me for the squaring cut. I'm going to say, yes, I definitely want to add the squaring cut. I'm going to square the left edge and the bottom edge based on this particular machine and this particular optimization pattern. And I'm going to trim half of the 10 millimeters away. So this is probably the third key thing. I recommend setting the trim amount here to half of what your sheet trim is, or your material trim is. So if you've got 10 millimeters there, it's 5 millimeters here. If you've left it on 5 millimeters over there, you would go to 2.5 millimeters here. So just remember, in rule of thumb, enter half the value here that you do for your material trim, and click OK, and then it's going to export the 2 files, right? That's all you would need to do. But I'm going to dive into this sheet and just show you this a bit clearer. So when I press generate G code, when I'm inside a sheet, you will see the generate G code dialog appear, right? If I click the flip sheet button, it goes back to the squaring cut and shows me that option. So I'm going to say same thing, 5 mil. The reason why I'm doing this is to show you the difference, right? So we've got all of our drilling toolpaths on this flip side of the sheet. Okay, and then when we've got our toolpath, you'll be able to see where the toolpath goes, right? So you'll be able to see that it's running down here and along the bottom. So you'll know from doing this little simulation 2 things, right? My tool is 10 millimeters wide. So the line is right along the edge of that sheet, because to take 5 millimeters away, the line would need to be on the edge of the sheet, running right along the edge, and that's taking 5 of the 10 away. Now, as you can see, if it starts here and comes all the way down to the bottom, right? If your sheet size is bigger than that 1205, you're definitely going to be trimming some of it off, and you're trimming it down to the correct now value of 1200. If your sheet size was smaller than that, the tool's actually going to miss the edge of the sheet and not trim it to the correct size. So that's why I recommend underestimating the sheet width. Reason why I recommend overestimating the sheet length is this tool is actually going to stop right on the edge of that 2420. Now, if you've estimated 2410 and your sheet's actually 2415, you're going to have this like little tiny notch at the end there that's not going to be trimmed away. That's why I recommend overestimating the length, so you can definitely make sure you're trimming enough away to clear that squaring cut. And then flipping back, the other side is obviously going to be all of your pockets and tooling, for the shaker door or whatever the flip side is, right? When you do the squaring cut, it does depend on your machine origin. So you might want to choose the third option in this case rather than the second option, or the first option, I should say. because you can then see where that trim goes. So in this case, we're trimming from the end here all the way up and all the way across, which in this particular case, that's the exact option that I would want, because I'd want to trim it closer to where the parts are nesting to, not the furthest away from them, if that makes sense. So the answer to that is obviously going to depend on setup. But the key rule of thumbs, just to recap quickly, would be get your sheet size right, increase your trims, and set your squaring cut to half of the trim value. You do those three things, and that's recommended in our help document that I mentioned at the start. You're going to get a really nice result, provided you've got your machine origins dialed in correctly. All right, let's see. So Brendan's saying, can you show us how to do a parameter-based drilling for the tightest tech form drill-based runners? I have a 500 and a 450 runner in front of me with the sizes ready to go. Cool. So let's jump out of the optimizer, and we'll go into libraries and hardware, and then we'll come down to the guides and look at the tightest tech form guides. So I'm not too sure if you're referring to Slimline or DW, but I'll just assume Slimline, probably the more popular one. So as you mentioned, you've got a 500 and a 450. So it does depend on the height as well. Obviously, they're all individual, but I'm going to click on a 500 and press the pencil symbol to get into the editor. Let's go ahead and see if we can, I can't really zoom in on this to show you this a bit clearer, but hopefully you can see it clear enough. So you've got your bottom detail here, right? And what this is the ability to click into the bottom and then assign some machining to this. The default part size is only 150 by 300, which is very small. Obviously, the length's probably going to be more like 500 and the width's probably going to be more like 450 or, 400 or something. So you can go ahead and just change those sort of sizes to see it a bit more in the right sort of perspective, I should say. And as you've sort of mentioned in another message there, you've said that it's 9.5 millimeters in from the edge, 15.5, I'm assuming from the front, 167.5, 319, and 465.5. So I'm assuming the 465.5 doesn't actually machine on the 451, but the other three do. So what you could do here is you can go into your operations, right? And this I can make bigger. So let's make this bigger. Right. So we're looking now at the bottom. Now, you kind of want to, what I'd always do first would be to check if this is on the top or the bottom, like which side are we looking at it, because we probably want to flip it over. Bore a hole, and I would dive out and check, but just for the purpose of this, I'm not going to go through all those steps, just to show you the idea of what you're doing here. So your depth, you can set here. I'm going to say 12 millimeters, 5 mil deep. Again, if you're using a Euro screw, that would probably be what you would do. If you're just spot boring it, you would probably change those values. So here's the hole here. This nominates that this is the front edge, back edge, that's the right, and that's the left. So it's shown there nice and clear for you. So what you said about the 15.5, that would be 15.5 in from that front edge, right? And then the Y value here would be the 9.5. That would be the first hole. Now, by default, if you just do that and you leave the anchor in the middle, what's going to happen is it's going to scale from the middle. So as that part size changes, your hole's going to move. So this is a sort of key thing, and that's the reason why I wanted to show you that part size, right? And you can do a stretch and width test to show you this. So let's say if I decrease the length, you can see that hole getting closer to the front edge. As I go longer, you can see that hole getting further away from the front edge, right? So the way to get around that, two options. You can click into the calculator and type the value in there, which is going to lock it to that value, or you can change your anchor. So for this particular hole, if I anchor that to the front and the bottom, so that bottom left corner, and now I go into my shape and I look at my stretch test. Let's say I stretch that out or stretch that back. The hole is not moving from that front edge. It's staying consistent. And as I change my width, it's staying consistent as 9.5 in from that edge as well. So the bottom ones, in essence, it's really simplistic. You don't even need formulas. You could just, do that, go copy, paste, and then now put your next hole in. So your next one would still be 9.5 in Y, and it would now be, I think you said 167.5 in X, and again, still stretch from the bottom left, and then next hole. And we would go in at, let's say, 319.5 and 9.5. And again, same thing, it's still stretched from that bottom left. And then copy and paste. And the last hole here would be, you said 465.5 and 9.5. And same deal, still stretch from that position. Now, I would use the hide function to control whether or not I want that hole to appear if you're going to copy and paste this to, say, a 450 runner, right? So I would click the calculator, and what I would say by default is that this hole is not hidden. So 0 for hide means don't hide it. 1 for hide means hide it. So if I said 0 and just add that, by default, it's not hidden, which just means by default, if I get out of there, it's not ticked. Okay, so it's there, it's visible. Now what I want to do in the if column is create an option. So I'm going to say if the part length, so part L is part length, is greater than or equal to, let's say 500, or depending on the draw, that might actually be like 490 or something, right? So you need to know kind of the cut size of that to when you want that to turn on. So I'm just going to play it safe and go a little bit less. Then I want to make sure that this, actually the other way around in this case, sorry. So this is going to be when it's less than, say, 450. So I'm going to do it the other way. I'm going to go less than or equal to. You can do it either way, but on how you want to look at it. So if the part length is less than or equal to 450, then I want to hide it. I want to get rid of it. So I'm going to do it that way. So at the moment, it's greater than 450, right? So if I go to my stretch test here, it's at 500 at the moment, right? And if I reduce my length in my stretch test, so you can see as soon as I've gone under 450, that hole disappears. As soon as I go over 450, a hole reappears. So really simple, just a simple equation there to say, if your part length is less than 450, then hide it, turn it off. I don't want it. So you can control that fairly easily, right? And then you can come in and, basically have that hole on or off depending on the answer there. And, you could basically change this one to be like if the part length is greater than or equal to 450, or, again, depending on what you want it to be, go 460. And then you might say, don't hide it, so you've got the ability for it to sort of turn on and off depending on that size. Now, repeat that for the top, but this time in what we do is if we copy and paste this front hole, and we go that 15.5, and then the top value, I could do two things. I could either go to the width and put in a width that says part width minus 9.5. That's pretty easy to do. Or I could position it at, if I've got my example at 400 and I've got, it's 390.5, I could type that in Y and then change my reference here. So the reference is only important if you're not putting a formula in there. If you are putting a formula in there, the formula overrules the anchor. If you don't have a formula, you would want to get your anchors spot on. So hopefully that makes sense. Obviously repeat that for the rest of the holes. And then the final step would be in your shape tab here is to go save to library and give that a name. So this might be your Titus draw bottom. And then, just save that wherever you want. I'm going to leave that in the miscellaneous category. And then once you've done that, I would simply then go into the 450, edit, click on the bottom detail, load from library, and grab the Titus draw bottom and drop that on. And that's it. You'll see the whole outside because of the sample size, but again, you can change that to whatever it needs to be. I wouldn't get too bogged down on the sample size thing. It does confuse a lot of people, but pretty simple just to go through and add those holes in, create one part template with all of your holes, and then just go through your library and assign that everywhere where you need it. No worries, Brendan. Glad that helped answer that question for you. Let's see. So Kevin said, I've tried doing the flip operations as explained in your video as well and confirmed that my 0 machine is dialed in. However, I cut, my flips are a little off. Not sure how to fix it. Look, you probably reach out to help desk. We would need to specifically look into that exact scenario with your machine, your situation. There can be a couple of things that make flip sheets sort of not viable for certain customers. And it can be that if your pins or the stops that you're pushing the part against has too much movement in it. I know some older machines with a lot of wear and tear means that when you push the sheet against the stops or the pins, they actually can move or flex by 2 or 3 millimeters, which throws everything out as well. In that case, you're better off using the flip seat dowel method because you don't have pins that are sort of stable enough to support it. If you said that you've got your machine dialed, we would probably want to see some examples of that. So maybe if you could run that alignment test, take some photos of a tape measure showing that is actually the correct distances in from the edge, in from the pins. That would help us identify if your machine is actually dialed in correctly. A lot of people contact their machine supplier and their machine says, yeah, no, the machine's bang on, it's perfect, because when you drill something and cut something, everything lines up. And that's a very poor misassumption from most CNC providers, right? Because just because your regular parts cut and drill correctly does not mean that the machine's correctly aligned for flip side machining. Because as I mentioned, you're allowing 5 millimeters of trim on every component, which means that those pins can be out by that trim value, and you would never know until you go to do a flip side machine. So even though someone might be telling you that the machine is dialed correctly, it doesn't necessarily mean that it is. And I've seen this countless times because probably we get, no joke, a dozen customers a week reaching out to us with this exact scenario. We spend hours going through assisting them, and every single time it ends up being that the machine origins were not correct and not dialed in. I will make a note that make sure you're running the latest version of Mozaik, because back in version 10 point something, there was some misalignment of the G code in Mozaik. So as long as you're on version sort of 10.1 or higher, I'm confident that the G code is going to be correct coming out of Mozaik. So that would be my advice. Look, reach out to help desk, send through some photos of your alignment test with a tape measure on the photo showing that your machine is dialed in correctly. So yeah, you've just mentioned that it's an SCM Morbidelli. There's text coming out today to make sure everything was spot on. Okay, cool. So go through that. Look, if you find that for some reason when the tech comes that's misaligned, SCMs are a bit of an interesting one because they have different zones and fields, right? So when you're looking at a sheet on an SCM, you can control the zone of where that's placed, and you can also mirror zones. So we could say, look, place the code in like field A or field D or field H or E. There's like 4 different areas on an SCM. So making sure then that either they're not mirrored as well, because if we're sending it to a zone and it's getting mirrored or flipped in X or Y, it can also complicate things. But start with that alignment test, make sure that that's correct, and then take it from there. And again, if you have any problems, just reach out so that way we can assist you with it. All right. Time for one more question, which was from Gabriel. How to export the layout? So I think you're asking, how do you export okay, you could interpret that question a couple of ways. If you're talking about how do you export the G code layout, when you're in the optimizer, that would be pressing the generate G code button. If you want to print that layout, you're still there, Gabriel, feel free to just retype your question with a little bit more info. But from here, you would press generate G code and you would create the primary program or the flip if you needed flip sheet programs as well. That's going to export your G code. Your G code would then appear in the G code list, and you can go ahead and interpret that how you will. But the G code is set, where it goes is set in your preferences, and you can control where you want that to be. Okay, you're actually saying that you want to show the client in 2D. Cool. So in that case, that would be a multi-print. So from here, if I go to File, Print, and Multi-print, that gets me into the multi-print editor. So there's a couple of methods. In multi-print here, you can go ahead and grab a plan view, drag and drop that onto the screen. You can also drag elevation views and 3D views onto the screen and place them as you will. A nice thing in in later versions of Mozaik is you've got the ability to multi-select, right-click, and align. So if you want to align things to get them spot on, that way your plan and elevations are showing up. And then from here, you can print that to a PDF. So I just use the regular Microsoft print to PDF function. Go ahead and print that out. That's going to choose to save somewhere on your computer. So wherever you want to save that, I'll just give this a random word and press save. And then that will save to my desktop. And then I can open it from my desktop up in PDF and send that to my client. So very easy to do. The other option would be to go to File and Print Job. So from in here, you've got the ability here, you can print as much as you want or control as much as you want in here. You could have your job information, your floor plans, any elevations, and then just press print. Same deal here. You could go ahead and choose to print that to a PDF. So I would choose my Microsoft print to PDF function, press print, and then that's going to go ahead and do the same thing, pop up and ask me if I want to save that and what I want to call it. And that's more of an automated way without you having to manually drag and drop them. But multi-print is going to give you a lot more functionality to lay that out in the way that you want with your logo and everything like that on there. So that would be how I'd go about that. All right, guys. Thanks for everyone's questions today and everyone's time. I will catch you guys again next month. We'll be doing another live session in around about a month's time. I'll post a update on our socials with the date and time. It'll be another Friday at the same time, unless we sort of get feedback otherwise. But hopefully everyone's enjoyed this session. Thanks for everyone's questions, and look forward to catching you all guys next month. So stay safe and speak soon.